In this video, I'll walk through an example to illustrate the concepts of subgraph, proper subgraph, spanning subgraph, induced subgraphs, and edge-induced subgraphs. So we'll work through all of those terms here. Make sure you read through this section of the book before starting this video or before continuing on in the video. So we'll start with noting that, or recalling that a graph H is a subgraph of a graph G if its vertex set is a subset. So the vertex set of H is a subset of the vertex set of G, and the edge set is also a subset of the edge set of G. We can get a little bit more specific. We can say it's a proper subgraph if one of those two set inclusions is also proper. So that is, it's not the complete. The two sets aren't equal. So let's start there. So G is sort of our big host graph here for the rest of these. We'll start by pointing out that G1 is not a subgraph of G. So I'll write that below using our notation. So G1 is not a subgraph of G. And why is this? It's because G1 contains this edge UZ, which G does not contain, right? So the edge set of G1 is not a subset of the edge set of G. And so that breaks the conditions to be a subgraph, so G1 is not a subgraph of G. G2, on the other hand, is, notice it has a selection of 4 vertices from G, so the vertex set of G2 is included in the vertex set of G. As well, the edges of G2 are also included in the edges of G. In particular, these 4 edges also appear in G. So G2 is a subgraph of G. On the same vein, G3 is a subgraph of G. G4 is a subgraph of G. And G5 is a subgraph of G. Also, sort of trivially, G is a subgraph of G. However, G is not a proper subgraph of G because the vertex set is exactly the same in both cases, as well as the edge set is the same. So this is not a proper subgraph. But it is a subgraph of G. We can go through the rest of these. Since G1 isn't a subgraph of G, it can't be a proper subgraph of G. G2 is a proper subgraph of G, and so we could write G2 is actually entirely, I don't want to draw the equal sign under it. I want to say G2 is entirely contained in G, and that it's not all of G. It's not the same graph as G, and that's really what proper subgraph is telling us, is that it's not the same graph, but it is contained in it. And this is the same for the rest of these. Notice with G3, while the vertex sets are the same, the edge sets aren't. I'm missing this edge, and what? It looks like, yeah, I'm just missing that edge from G. So G has an extra edge that G3 doesn't. So G3 is a proper subgraph of G. G4 as well is a proper subgraph of G. And G5 is a proper subgraph of G. So proper subgraph is a little bit more specific. It adds the condition that they're not the same graph. So those are all proper subgraphs. Next up is spanning subgraphs. Spanning subgraph means that the vertex set between the two graphs are the same, but the edge sets maybe aren't. So in particular, let's take a look at G2. G2 wouldn't be a proper subgraph, or wouldn't be a spanning subgraph of G because it doesn't have the same vertex set. Same for G4. Notice I'm missing the vertex V in G4, so it's not spanning. G5 is also not spanning. I'm missing a couple vertices there. G3, on the other hand, is spanning. It includes all of the vertices that G does, but I'm missing an edge. That's okay. It's still spanning. So spanning is telling us that the vertex sets are the same. So hopefully you got that pretty well. The more sort of confusing topic, and that always takes a little bit of time to understand, is this idea of induced subgraphs. So vertex induced or edge induced. When I say vertex induced, the book just calls this an induced subgraph. I like to specify that it's induced by the vertices as opposed to induced by the edges, the other sort of spanning induced subgraph. So what does it mean for a subgraph to be an induced subgraph or vertex induced subgraph? Well, what this really means is that I can pick a selection of vertices from G. So I can form the subgraph by picking a selection of vertices of G and only including those edges if they are also edges of G. All right, so what does this mean? So maybe take a second and look through these examples and see if you can spot any induced subgraphs. So I'll point out G2 is an induced subgraph of G. So in particular, I'll let the set S1 be these set of vertices, V, X, Y, and Z. And my claim, if I say G2 is an induced subgraph of G, what I'm claiming here is that G2 is induced by this set S, S1. It's induced by S1. So I'm picking these vertices V, X, Y, and Z, and I'll only include the edges if those edges between these vertices also appear in G. So with this selection of vertices, V, X, Y, and Z, I'll mark those here, V, X, Y, and Z. Notice if I just sort of pluck out these vertices of G, if I just take those vertices and don't break any edges between those vertices, what I'll end up with is exactly G2. That's what it means for G2 to be a vertex-induced subgraph or just an induced subgraph of G. And that's written right like this, where we specify the vertices. Surprisingly, G5 is also an induced subgraph of G. So again, I'll pluck out the vertices here, U, V, Y, and Z. And I'll go up to G. I'll look at U, V, Y, and Z. So I'll take those vertices, and I'll only keep an edge if there's an edge between some pair of those vertices. So notice U and V aren't adjacent, and they aren't adjacent here. U and Z, U and Y are not adjacent to each other, and they're not adjacent here. And then finally, Y and Z are adjacent to each other, and they are adjacent here. And so G5 is an induced subgraph of G. It's induced by this set S2 of vertices. Let's pick out one that's not vertex induced. G4, for instance, is not vertex induced, or it's not an induced subgraph of G, because so here my set would be U, W, X, Y, and Z. And so if I go up to my graph, I look at U, W, X, Y, and Z. If this were induced, I'd have to include all the edges between those 5 vertices in my graph. But as you can see, we lose the edge UX, and we lose the edge XY. Those don't make an appearance here, but they would if it was an induced subgraph. So this is not, G4 is not an induced subgraph of G. G4, on the other hand, is a edge-induced subgraph of G. And so that brings us to the next topic here, and that's edge-induced subgraphs. So the idea is similar. Instead of picking a selection of vertices and keeping all of the edges between those vertices for the induced subgraph, what we'll do is we'll take a selection of edges and only include vertices if one of the vertices is incident with one of those edges that we've selected. So G4, I'm claiming, is an edge-induced subgraph. So let's see, what edges do we have here? Maybe I'll call this S3. And I'll pick out the edges, UW, WX, WY, YZ, and XZ are the 5 edges of G4. So what this is saying is I can obtain G4 by selecting these edges in G and including the vertices that are incident with those edges. So maybe let me use green for this. So UW, I want to select that one. WX, I'll select that one. WY, this one. YZ, and finally XZ. So if I just take the vertices incident with those 5 edges, along with the edges, I obtain G4. And so we say G4 is an edge-induced subgraph of G. So hopefully that helps you with vertex-induced, edge-induced subgraphs. It's a little bit tricky of a concept. Keep playing around with it. And that's it for this video.